All right. So, did anybody get a chance to see what all we are going to cover? So, we are continuing with Unit 4, which is Advanced Math Foundation. So, okay, we got Sarah also. Hello, Sarah. Where's Neil?
He's joining in 5 minutes.
Okay. All right. So we are continuing with Unit 4, which is Advanced Math Foundation, and in that unit, the things that we will cover today in the class are. Let me read it for you guys. So we'll talk about rational expressions and the operations with rational expressions. Then we'll talk about non-linear functions, where we'll talk about what is non-linear function, what is the understanding of a function, what is a composite function, and then also try understanding what is the basic difference between a function and not a function, so that when we go from a linear function to a non-linear function, we are able to take this baggage of information with us and you apply that while solving problems. Okay, so that being said, let's get started. So, anybody else join in between? Okay, no, I think we are good to get started. So, first thing first, a little bit of relief from winter or from the cold weather, and it's going to get better. So, today is the last class, probably today and tomorrow, probably when we will have heater in the classroom. Then gradually we might not have the dependency on heater going forward, and then we'll have to look at finding out AC in the classroom. All right. Hey Vishal. Okay. So conceptually, if you look at it, there are two things that we are wanting to cover today. One is dealing with rational expressions, and second is what is function, different variants of function, and how do we relate that with nonlinear function. Yeah, Dev, you are trying to say something?
No, sir, sorry.
Not a problem. Yeah, it's okay. So now first thing is, what is rational expression and how do we deal with different operations of rational expression? So basically in the class today, there might not be a lot of things conceptually to be shared, but then it'll be more practice driven. So we'll do a lot of practice to see how much our hands are dirty with these concepts and what we can do for kind of fine tuning or expediting the way we solve these problems. Okay, so that will be our key objective for this class. Now, let's first start with rational expressions. So, I want some of you in the class to explain or tell me what is the basic understanding of rational expression that you guys have. What is rational expression? And any answer is a good answer. Don't worry about that being wrong or right.
A expression in the form of a fraction.
An expression in the form of a fraction. Okay. Any other thoughts? Any other simpler way to define? Yeah, Prisha.
Like an expression that shows up the ratio of two different polynomials.
Okay. Yep. So that is another way of saying an expression which shows ratio of polynomials. Okay, Chris.
Yeah, sir, I was going to say the same thing, like both the expressions are like either a monomial or a polynomial.
Yeah. All right. So yeah, I mean, conceptually, at a high level, I think everybody is clear about what is rational expression. But just for the sake of being complete with how do we start our journey, rational number, we know what is a rational number. Something which can be written in the form of a fraction. You have a numerator and you have a denominator. Similarly, we know what is an expression also. So when we say expression, meaning something which is expressed in the form of variables. These are all expressions. Why expression? Because there is no outcome. There is no equal to sign. So these are all expressions. So we know what is a rational and we know what is an expression. It's a combination of both. Meaning when we are representing expressions in the form of a rational number. Like now Chris and Prisa explained that when an expression or a polynomial is represented in the form of a rational number. Same as what you said, correct? So rational number and expression when combined together, that's what forms a rational expression. So now if and you said everybody knows what is monomial, what is polynomial, right? So when you have an expression with one term, that is monomial. When you have expression with multiple terms, that is polynomial. More than one term is polynomial. Yeah. So taking that information into account, now we all are clear with the concept that, and whenever we say rational expression, we are talking about something in the form of this. Let's say this. Yeah. Because here we have monomial. I mean, a numerator has more than one term and it's an expression. There is no equal to sign. The denominator also has polynomial. This is also an expression, but it is in the fraction form. You have a numerator and you have a denominator. That's the first thing that we all know about what is a rational expression. Now, like we know this is a number. Now we are trying to talk about how do we deal with the operations, right? I mean, if somebody says, okay, find out 3 by 6, very easy. You know that 3 I can write as 3 into 1 and 6 I can write as 3 into 2 and I can do tic-tac-toe, I get 1 by 2 as my answer. So what did we do? We had a rational number, we simplified that to get a much easier number to deal with, or a simplified form of that one. You call it simplified form, you call it equivalent fraction, whatever you call it. Up to this is fine. Same thing or similar thing we want to do with rational expressions also. Meaning if I have a rational expression, do I have a way to simplify it? And how would you simplify it? If you have a rational expression, meaning you have something in the numerator as expression, you have something in the denominator as expression, and you want to simplify it, meaning here what did we do? We have something, we factorized it. And then we tried finding out something which is common. And we knocked out the common ones, and that is how we got the simplified one. Similar thing we can do with rational expressions also when we talk about simplification. So let's look at one scenario. Let's say I have x squared plus 5x or 6x, let's say, plus 5 divided by x plus 5. Okay. And if I say simplify this, so the main concept that we have to keep in mind is we have to look at if there is a way to factorize. Because if I can break this into something like a into b, and then I have something like a into b or b into c, then b into c, I can say okay fine, b and b I can knock off and then I have a by c. That is a simplified form of this expression. Now when I'm looking at this expression to simplify, I will give you guys one quick rundown of how I will do it, and then probably we'll look at some more problems to make sure everybody's hands get dirty. Now, when I look at x squared plus 6x plus 5, we are trying to factorize it, meaning we are trying to break this into something like a into b. Now, our obvious pick is this. If I can break this down to a plus b whole square or a minus b whole square form, or a square minus b square resulting to a plus b into a minus b form, that's an easy pick. But then a plus b whole square, we know that it's a square plus 2ab plus b square. This constant has to be a square. 5 is not a perfect square. So this strategy doesn't work. Same is the case with a minus b whole square also. Your constant has to be a square of something, which is not the case here. Then we have to go to the second route. We have to take the second approach. where we look at, okay, let's look at the, and this is anyways, in the lowest exponent form. So we'll probably not touch this one. We'll look at this one. If this can be broken down into two pieces, something into something, and then we'll see if we have something in common here. I mean, it doesn't mean that every expression that you have, you'll be able to simplify it. If something is already in the most simplified form, you'll have to just live with it. You don't have a choice. But here, when you have this, we are trying to figure out if I can break it down, x squared plus 6x plus 5 into something. Now, this is my a is here 1, c is here 5, and b is 6. Right? If you are comparing that with the standard form of a quadratic equation, this is a quadratic equation, right? Because the maximum power is 2. Is everybody with me, or I'm just rushing through very fast? Is everybody with me?
Yes, sir.
Okay. Alright. Now, this is a quadratic equation. We are trying to see if I can break it down. So we'll compare this with the standard form of a quadratic equation, which is ax squared plus bx plus c. And then we saw my a is 1, my b is 5, and my b is 6, and my c is 5. So the second strategy that we take is multiply a and c. So a into c gives me 5. Yeah. So okay, I probably chose. I'll just make a small tweak to this, okay, so that we get a solution here in an easier way. Okay. Now, what will happen here? So
It'll be easier with the positive.
Yeah, it'll be easier with positive x plus 5
Yeah.
by
Yes.
x plus 1.
yeah, so that's what. So 5. So my approach is this. I mean, maybe if the question is wrong, we'll figure it out. So my first approach is multiply a and c and get a 5. Now we have to look at what are the factors of this. It is 5 into 1. So yeah, if I have 5 and 1, if I add these two, I get a b. That means it works. So here x squared plus 6x plus 5, I'm just looking at this part. This part will come later. So I can say x squared plus, so 5 and 1 together, by adding them we get a 6. So this is fine. So what we'll do is we'll break this into 5x plus x plus 5. Now take these two things together and these two together. So here when you take x common, it becomes x plus 5, and here you take 1 common, it becomes x plus 5. Okay. So this can be represented as x plus 1 multiplied by x plus 5, because x plus 5 is common here and common here. So you got this. So basically our x squared plus 6x plus 5 became a factor of x plus 1 into x plus 5. Now if you take this information and plug it here, what you see is x squared plus 6x plus 5 became x plus 5 times x plus 1 divided by x plus 5. So now we clearly see that we have a tic-tac scenario, tic-tac-toe scenario, right? I mean, I playfully call it tic-tac-toe because you can knock off the common things, this and this. So something that was looking like this became this. You cannot simplify it any further. This is the most simplified form that we got. Yeah. So when you are looking at a rational expression, simplification when you are talking about, the only thing that you have to keep in mind is there a way I can factorize my numerator and denominator? And once you are able to factorize it, then you will see if there is something common. If there is something common between the numerator and denominator, you knock it off and you get the simplified form of the rational expression. So let's solve two problems real quick, and then we'll go to the next part of it. Now, is this part understood so far? Thanks to some of you for correcting me, because I was grappling with myself and you guys were able to correct me, which is good. That's a good sign. So your teacher doesn't have to give us a T. You all have to. So even if I'm going wrong somewhere and you are able to catch hold of me and say, no, sir, this is not right, that's a very good sign. Now let's look at this. Let's say I have x square minus 3x plus 2 divided by x minus 1. This is one. I want you guys to simplify it. And second one is okay. So you guys have only 5 minutes for solving this so that we can do more. And let's do it in a more playful way, okay? Don't feel the stress. This is the fun part of what we already know. We're just practicing it, okay? Can I assume everybody's trying? At least a 1 yes. Who's going to bell the cat? Somebody has to say yes.
Yes.
Okay. All right. You're just playing with these two questions, okay? X square minus 3x plus 2 by x minus 1 and x square plus 18x plus 11 by x plus 2. And I'm not saying that there's a possibility of a more simplified answer always. There may or may not be. If this is the most simplified form, you have to tell me, yes, this is the most simplified form, and I'll validate that. Yeah. So Rehan, Sivatsav, Snarka, Vihan, everybody trying?
Yes.
Yes, sir.
You're not cold, right, Puneet? Okay. Yes, Vishal.
For the first one, I got parentheses x plus 3.
X plus 3.
Yeah.
Okay.
For the first one, I got parentheses x minus 2.
Okay. I got another answer x minus 2. Okay.
Wait, my bad. I meant negative 2, yeah. Because I got confused between 3 and 2.
You got x minus 3?
Minus 2.
Okay. So both the answers I've got for the first one is the same. So you guys are right or wrong in a group. Let's see. Yes, Prashar.
I got the same thing as.
Okay. Yeah, Dev.
I'm sorry, I got the same thing.
For the first one. Okay.
Yes, sir.
How about you, Vihan?
Yeah, I got the same thing for the first one, and then for the second one, I don't think it's
You can't
simplifiable.
You cannot simplify. Okay. All right. Yeah, Chris.
So same thing for the first one. And
Okay.
I don't think, the second one, I think you have to use the quadratic equation because it's not factorable.
Okay. Yeah, just
I got x plus 9 for the second one.
you got x plus
9.
x plus 9 for the first one.
Second one.
You got x plus 9. Okay. All right. Okay. Anybody else? Shravya, Dhanushri. Sarah, Neil. Anybody? Narka? No. Okay. You guys are a little too shy. Okay, don't be shy. Though I'm your math teacher, but I'm pretty much everybody's father's age. So I'm a fatherly figure. Don't have to be shy of your parents. Okay. So, anyways, let's look at what everybody did. So this one, x square minus 3x plus 2, this is not a perfect square for sure. So first option is ruled out. Only option we have is a into c approach. So a into c gives me 2 into 1, which is 2. And the only factor is 2 and 1. That there's no other way to factorize it. And 2 and 1 if I put together, that gives me a 3. But here in this case, it's minus 3. So probably I will use minus 2 and minus 1. Because if I multiply these two, then also I get a 2. So that works. So here in this case, this part becomes x squared minus 2x minus x. So that put together is minus 3x plus 2. So you will take these two together, and divide by x minus 1. So here, this becomes, when you take these two together, take x common, it becomes x minus 2. And here you take minus 1 common, which becomes x minus 2 by x minus 1. So what we see clearly here, this becomes common and then x minus 1. So this becomes or gets factorized as x minus 1 times x minus 2 divided by x minus 1. I will not tell you what to do next. Yeah. So everybody got the right answer. Wonderful. Now here, look at the second problem. X squared plus 18x plus 11. Okay. Now 11 a into c. See again, 11 is not a perfect square. The second option, the only option that we have is do a and see how you can break b into two parts. So here a and c is nothing but 11 into 1, which is 11. And this being a prime number, there is no other factor that you can think of. So it can only be 11 and 1. These are the only factors that you have. And by adding, multiplying, adding, subtracting, whatever you want to do, you will never get an 18. So that means you cannot go that route. So as Chris said, the only option we have is we can apply the quadratic formula for getting the answers for x or the value for x. You're okay? Not cold, right? Okay. If you are getting cold, you can get a little closer to the heat. Yeah. Now, so that's the option you have. Now, so you can simplify this for sure. Other thing that you can probably go one more step further is see if there is a potential possible answer for this or not, and that comes from your understanding of discriminant, which is nothing but square root of b square minus 4ac. If you do b square minus 4ac, this is 18 square minus 4 times a is 1 and c is 11. So this will give a positive value. That means there are solutions possible, but as far as simplification of the quadratic expression is concerned, as far as simplification of the rational expression is concerned, this is your best bet. You cannot go further. So that's why I was giving you guys a clue, saying that you cannot. There could be questions which you're not going to simplify, meaning that is already in the most simplified form, where it's given to you. So don't have to worry about it. So everybody clear on that, right? Any doubt? No? Okay. Let me flip my question and make you guys think. In this question, in this equation, let's say, in this expression, what would have been a possible equation to get a factor? Now I'm saying don't introduce a new coefficient. Was there a way for us to flip the coefficients, meaning a, b and c values, and see if you would have still got an answer for this?
18 and 11.
Yeah, Vishal. Sorry?
Put the 18 and 11 and you could
Swap these two?
Yeah.
Yeah, Vishal?
My bad, I didn't mean to click it.
That's okay. So you guys got the question, right? I'm saying that I, being a teacher who was acting dumb when I was framing this question, that is how I gave you a question which was not possible to be simplified. So I'm saying, if you had this question and I'm saying, okay, I'm giving you the option of swapping a, b and c values, meaning the coefficient of x square or x or the c, swapping them to still be able to break it down. So yeah, Vishal, what would have been your answer? I got one answer from Praneeth. I
We
will not.
can switch 18 and 11 because 9 times 2, which is 18, and 9 plus 2 is 11 too.
Okay. So see here the cat. I mean, nobody will give you this kind of a question, but I'm just making you guys think. Now, always look at the scenario. Okay, when you multiply this and this, as soon as you come to a point where your A and C multiplication is giving you a prime number itself, that means you are kind of having your hands tied. Right? You cannot. This is the only option you have, and that never gives you this clue. So it's more workable when your A into C gives you a non-prime number. Then you have more options to play with. I mean, I'm not saying that every time by swapping this will help, but the possibility is more, because if your multiple of A and C is a non-prime, that means you have more factors. The chances of meeting that is more. So yeah, if as Vishal and Praneeth said, if I put 11 here and 18 here, now you see 18 into 1 is 18, which is a non-prime number. So you can have 1 into 18 as factors, 2 into 9 as factors, 6 into 3 as factors. You have more options. The possibility of getting a split is more when it's a non-prime versus otherwise. Yeah. So this is called a method of elimination. Okay? Meaning, it's not that every problem you'll get a straightforward answer. Sometimes you have to think in the reverse direction to get to the solution. So that's why it's more of a playful thing than being any stressful subject. That's what I keep on asking you guys. Are you guys okay to digest what I said, or you find that cryptic? Okay. See, I'm a very greedy guy, okay? I keep waiting for getting at least one yes or one confirmation so that it gives me a confidence that, okay, I can move on. Now, this is one part of it. If I say, how do you simplify it? So, you guys have fair understanding of what would be your approach. Now, if I mean, here we are going to talk about the other operations with rational expressions. If I say x squared divided by 3x minus 7 or 3x minus 9 plus x by x minus 3. So this is a rational expression, this is a rational expression. We're talking about adding them together. So one simple problem that I'll solve, and I'll keep the complex problems for you guys. So this is nothing but a fraction. This is nothing but a fraction. We'll do the same operation like we do with fraction. So here I see that if I take 3 common, it becomes x minus 3. So what we see is this is x by x minus 3, and this is x squared by 3 into x minus 3. So here, first thing you have to always do is take the LCM of these two. So LCM of these two, same thing, like you do always. So first is x minus 3, it becomes 1, it becomes 3, and then you take 3 out, 1, 1. So 3 into x minus 3, this is your LCM. When you look at the first term, this is same as this one, so it becomes 1 times the numerator, which is x squared, plus here it will be 3 times of this, will get you this value, so 3 times of the numerator, 3x. So it becomes x squared plus 3x by 3 into x minus 3. There is nothing that you can do right now, because here you have, if I had a minus here, that would have been a different story.
Wouldn't the front product be x squared plus 3x divided by 3x minus 9? And then you could knock off the 3x's.
What is that?
So wouldn't it, the final product would be x squared plus 3x divided by 3x minus 9 when you
Yeah.
So then 3x and 3x can get knocked off, leaving you with the x squared divided by negative 9.
So you're saying that x by x minus 3 you can take common and then
No, so you would have that in this. You could have knocked off 3x and put this.
no, you cannot knock off 3x. You cannot knock off 3x like this. This is not possible. This is not right. Okay. So small confusion here. Okay. If I have x squared by 3x squared, let's say 3x squared minus 9 or plus 9, whatever it is. Okay. Remember this. Tic-tac-toe is a formula that only works when you are dealing with multiplications. If you have a plus sign here, I cannot knock off this and this. No ways. Never go this route. That will be a big problem. Let's say, let's look at it one more time. Let's say if I have, so whatever I did, you guys followed it, right? No. Okay. Anyways, let's clarify one thing quickly before we move on. Let's say I have 4x squared plus 8 by 4x squared minus 7, okay? Or 4x squared plus 9x by this, okay? And I have a situation where I have 4x squared into 9x divided by 4x squared. These two are totally different scenarios. Here you are only dealing with multiplication. There is no plus or minus sign. So if you have plus or minus sign, then you cannot do tic-tac-toe straight away. You have to have things written in the form of this and this, and then only thing that is common that you will knock off. If you have a plus sign or minus sign, you will not break it this way. We will come to that operation as well. Is everybody clear about what I am trying to explain here? At least 1 yes. Okay. All right. Okay. Now, going back to this other problem. Let's try solving another problem. Just remember one thing. If you have any plus or minus sign in between in the rational expression, you will not touch or you will not go the tic-tac-toe route. You will not try knocking it off. Unless you have everything in the form of something into something, something into something, all inside the bracket. You will only knock off the things which is outside the bracket. Let's say I have 1 by or x by x squared plus 7x plus 12, okay, plus 1 by x plus 4, okay. Now if I have this and if I have to do I have to add these two expressions, okay. If I try adding it, the most fundamental approach would be, this is one thing, this is another thing. I will take LCM of this and then do it like a regular fraction addition we do. Are you guys with me? On the screen. Okay. Now here, if I this is apple and this is probably pumpkin. There's no relationship here that is visible. Now first thing we'll have to do is see if there's something common between this and this. Okay? Otherwise it will become a very complicated calculation. So let's see if there's something common between this and this. X squared plus 7x plus 12. Can I break this into two parts and then we'll see if there's something common here. So what we see is this becomes x squared. Now it's 1 and 12. 1 into 12 is 12. Now if I break this, it's 4 into 3, 6 into 2. So 4 and 3 together gives me a 7. So that becomes my clue. So this becomes x squared plus 4x plus 3x plus 12. So here, take these two common, Here it becomes x plus 4 and here you take 3 common, it becomes x plus 4. So now you have x plus 3 times x plus 4. Yeah? Is everybody with me so far? Prisha, Rehan, Dhanushri, Dave?
Yes, sir.
Okay. See what's up? Okay. Now, so from this one we see that okay, this x square plus 7x plus 12 is nothing but x plus 3 into x plus 4. So this becomes x by x plus 3 times x plus 4. And this is 1 by x plus 4. Now we see that there is something common here. That would probably help us make our life little easier than before. I mean, life never gets easy, but at least the math will become easy. Alright, so here, now it's like adding two fractions. That's what we are trying to do. This is your denominator, this is your denominator. First thing you have to do is find out the LCM of this and this. So we're trying to find out the LCM of x plus 4 and x plus 3 times x plus 4. So we'll pick up the common thing out, x plus 4 out, it becomes 1, it becomes x plus 3. And remember this, I am being so dumb here, I am keeping things in bracket so that no, I don't mess up with this. If I don't, I myself might get confused. So bracket becomes a good savior actually. Now here one is, not to worry, I'll take next one is x plus 3. This becomes 1, this becomes 1. I'm done. So my LCM is x plus 4 times x plus 3. We got x plus 4 times x plus 3. Yeah? So, now look at the first term. Here you have x plus 3 into x plus 4. So, one time of this gives you this. So, you will write 1 multiplied by your numerator, which is x. Plus, here this multiplied by x plus 3 gives you the whole value. So, this is x plus 3. What is your numerator? You have no numerator here. So, this is 1. So, it became 1 into x is x plus x plus 3 into 1. So, 1 into x is x plus 1 into 3 is 3 by x plus 4 into x plus 3. So, this became 2x plus 3 divided by x plus 4 into x plus 3. Did I do anything complicated? No. I just pretended to be super dumb by keeping, see there was no bracket here. I forced the bracket here because there was a possibility that I might get confused. And here, this one, first thing we did, okay fine, we all know that if I have an expression, I might have a possibility of factorizing it. Because if I were to factorize it and find something common, then I will take the common thing out, my LCM becomes easy, and then the whole solution becomes easy. Otherwise, this would have remained as one term, this would have remained as another term, and you would have picked up this multiplied by this as your denominator. And then first term would have been x multiplied by x plus 4, and second term would have been this multiplied by 1. And then that would have been a very complex calculation. It would have still gotten simplified to this form, but you would have probably done some extra steps. You would have spent more energy and time for getting to this solution. Okay? Are you guys with me so far? Okay. How about Dave, Ojas, Rehan, Sarah, Neil? Everybody, right? Savya? Okay. So this is the deal. If you have any rational expression to deal with, your first attempt is always going to be, do I have a way to simplify it? Because nobody likes dealing with this kind of crappy, complicated, cryptic problems, right? If I give you guys one situation, okay fine, x squared divided by x squared plus 16 x plus 64 plus x by x squared minus 16x plus 64. Okay? Or just to make it little easy, I'm giving you a little bit of clue here. I'm saying solve this. You can go the normal fraction addition route. Take this as one term, take this as another term, and find out the LCM, which will be nothing but this times this, and then you know, go find out this multiplied by this value, and then this multiplied by this value, and expand it and do the sum. But that is going to take a lot of your time. Your first attempt would be, do I have a way to simplify it? Here when you look at this is x plus 8, and this part is x plus 8 whole square. Plus, this is x minus 8 divided by x minus 8 whole square. Why you want to waste or burn so much of energy solving this problem going the complex route? If you simplify it here itself, it becomes 1 by x plus 8 by 1 by x minus 8. So this becomes 1 by x plus 8 plus 1 by x minus 8. Isn't that an easier problem to solve compared to this guy? So you have to first, as soon as you are dealing with the rational expressions, operations, your first attempt has to be, can I simplify it? Do I have a simplified form of whatever value I have, whatever numerator, denominator I have? Can I simplify this and then deal with it? Because if you go the longer or the conventional route, you will probably take 10 minutes to solve it. If you simplify it, if you remember the formulas and relate it, it will take 2 minutes. So you are actually saving 8 minutes for another harder problem that you might encounter. And that's the trick, that's the catch, that's the strategy that will help you save time wherever it's possible to be able to keep it reserved for doing reviews or for solving problems which essentially takes longer time. I mean, you don't have a way to do it faster. Yeah. All right. Everybody with me so far? Hope not getting you guys tired on a Saturday afternoon. Okay. Now let's see. Now we talked about how do we do fraction addition or subtraction. Addition subtraction works the same way, right? I mean, just the sign being different. Yeah. Now same thing applies for multiplication division also. If I say x squared plus 17x plus 72 divided by x plus 8 multiplied by x squared minus 3x plus 4 divided by x plus 9. So essentially we have this rational expression and this rational expression. We are trying to multiply them. And here also the same thumb rule applies. You have to first see what are your independent rational expressions. Yeah. I mean independent expressions also, numerator, denominator. And then you convert them into factor form. So if you look at this one, this is x squared plus 9x plus 8x plus 72. Okay. First one will break into this. I'm not telling you why, because you guys, I've told you guys enough, so I will probably not go there. By x plus 8, and this is nothing but x squared minus 2x. You can do that. Yep. So, let's say no, this will not be correct. So if I say see 4 will not work. 4. Okay. Let's say 3. That will work. It will become x squared minus 2x minus x plus 3. No. So let me just put 1. Okay.
So
1 plus 1 will be 2. What am I doing here?
you could have just kept it 3, and instead of a 2, it'd be 3 times 1 because 3 is prime.
Okay, anyway, let me not struggle so much with this because I'm trying to find out an equation. So let's say minus 3 is 4 minus 1.
It would be
Yeah.
x minus 3 times x minus 1.
Yeah. Okay. So yeah, this will work.
Yeah, that would work.
Yeah.
We
This
had
will
a
work.
2 before.
Okay. So this was maybe I had put 4 here. That was wrong. So it will be x squared minus 2x minus x plus 3 by x plus 9. Here this becomes x plus 9 into x plus x. This becomes x minus 2 into
No. You wouldn't have a 2, it'd be 1, right?
yeah. Yeah. Now right? Yeah. 3 minus 3 plus 1. Yeah, this will work.
Okay,
Yeah. So x minus 3 into x plus 1 divided by x plus 8 and x plus 9. So again, sorry for this confusion with my calculation being wrong. Let's say these are the rational expressions. What I'm trying to show here is whenever you have rational expressions to multiply with each other, your first attempt has to be factorize them, and as soon as you factorize them, you have no plus minus business outside the bracket. You have only multiplications. Okay. Now, when you come to this point, then you know that okay, I can knock off these two, I can knock off these two. Then I'm left with this. So you have to. I mean, whenever you're dealing with rational expressions, be it adding, subtracting, multiplying, dividing, you will always look at factorizing it and then knock off the common ones from the numerator and denominator, and then you simplify it. Yes, Chris.
Wait, sir, how will -3 and 1 work? Because if you do -3 times 1 is -3, but then yeah, you are getting -2, but then aren't we trying to achieve the +3 and not -3?
So here, see,
Easier.
okay, let me look at, okay, so good that you guys are double clicking on this one. Let's say if I'm trying to break this down. So 3 and 1, so this becomes 3 and 1. So 3 and 1 is 3, so 1 and 3 is what I have. How do I put 1 and 3 together to get a minus 2x? So minus 3.
But if you do -3 and 1, then you're getting -3. But then, as you said,
Okay.
you're trying to achieve.
Okay.
But I mean, the equation that will work would be x squared minus 2x minus 3. Right?
Yeah. So that's the correction. So basically, I'm not going to that one for now. The message or the understanding that we are trying to build here is, and you guys are right. Okay, I mean you guys are doing more practice than me. So if I'm missing something, good that you are paying attention and you are finding out what number we chose was incorrect. So the approach that you have to always follow is how do you factorize it? Once you factorize it, then you deal with it. Be it multiplication or division, same thing. I mean the catch here or the main thing to consider here is you factorize your numerator and denominator and then you deal with them so that you don't end up dealing with a very complicated equation or an equation or an expression with lot of calculations involved. Yeah. But yeah, Chris, you were right. I mean, this calculation was going for us. Yeah. But did everybody get the message with respect to what we are trying to do? No? Not happy with the teacher what he did just now? Okay, let me put it this way. Is everybody clear with what we are doing? Now, there's another thing that there's somebody named Alex who has joined just now. Alex, you are in which grade?
It's me.
Okay. So Geo, your class starts in 8 minutes from now. So you are early for the class. Okay.
Okay.
All right. So going back to yeah. So going back to dealing with operations with rational expressions. There's another concept that you have to always keep handy with you is the concept of equivalent expressions. Meaning, if I have 4x plus 3y plus 6, or let's say 4x square plus 3x, let's deal with only one variable for now. If I have 4x square plus 3x plus 6 as an expression, this is equivalent to 2 into 4x square plus 3x plus 6. Meaning, multiplying this expression with another number or dividing that with another number doesn't do any harm with respect to how you are going to deal with it. So let's say if you have an expression like 4x square plus 6x divided by 3x plus 8. This one here, or let's say if I just say 3x. Here, even if you are not able to factorize this, but you know that okay, I can take things common. Take common things out. So you see that 2x is common in both of them. So it becomes 2x plus 3 divided by 3x. So now you have everything in the factor form. You can knock off this x with this x and you have the answer. So the concept of equivalent expression or taking something common out or dividing by something common between numerator and denominator, that also helps you solve the problem. Let's say if you're talking about 4x plus 3y by x minus y. This might not look relevant in this scenario, but it's very important for us to remember that multiplying something with the numerator and denominator doesn't do any damage. If you put an 8 here and put an 8 here, this will be the same equation like before. So apply these concepts for simplifying your rational expressions. So a summary of what we have done so far. So we talked about what is a rational expression. We talked about what is the relationship between a rational number and an expression and how do we relate these two concepts to deal with everything that we do. And we already know how do we deal with operations of rational numbers, adding or subtracting a rational number or multiplying, dividing a rational number. Same approach we can take here. The only thing that we have to be considerate about while solving the rational expression problem is look at ways to simplify. Meaning, when I say simplify, every expression, see if there is a way to factorize it. Don't deal with 4x plus 18 as this. You can always say, okay fine, I will take 2 out. I'll deal with it now. If you have anything that you can take out as common between the terms that you have, take it out so that it converts into a factor form. When you have something into something in the numerator and something into something in the denominator, obviously that will give you ways to optimize it or simplify it, but don't deal with things without simplifying, because 95% of the problem that you guys will deal with respect to rational expression will be all around how do you simplify it. If you simplify it right and don't make the mistake like what I was doing, I mean obviously the question was not right, you guys will not get wrong question most of the times. Yep. Say that?
X squared minus 4x plus 3 could avoid.
Okay. So that's okay. I mean runtime, sometimes the brain doesn't process at the same speed. So that's where we go wrong, but that's okay. That's perfectly fine. So what I'm saying is, whenever you're dealing with rational expression, it doesn't change much. Mandeep, stop playing with emojis. This is not your class. You are 3 minutes early for the class, and no place for emojis here. Alright, so always look at simplifying it, because that will save you a lot of computation time and the chances of making mistake would be less. Yep. Alright, so let's look at one last example, and then probably we'll talk about the remaining topics, the nonlinear function, in the class tomorrow. Okay. So here like we deal with rational expression multiplications, we can deal with rational expression division also the same way like we deal with rational numbers. Let's say 9x plus 3 divided by x plus 1 by x plus 3. Nothing happens here. Keep everything in the bracket so that chances of making mistake is less. And then divide x, hold the door. And then you know that when you have a division, you can change to multiplication and then flip. And then you do rest of the things. Alright? So that brings us to the end of the class. We will, I request you guys to do some unit test with respect to this particular topic where you deal with rational expressions and the operations. And let me know if there is any problem that you came across which was difficult and interesting enough where you struggled with, so that we will try solving that in the next class and see if there is any gap with respect to the understanding that we have tried building in the class. Yep. Alright. Any questions?
No, sir.
Okay. Alright, so one thing that you guys observed is if you don't do enough practice, chances of going wrong is more. That's where my lack of practice was visible to some of you, and that cannot be the case for you guys. So request you all to keep on doing practice more and more so that the chances of runtime calculation or mistake is minimized. Yep. Alright, so I'll let you guys go and then see you guys tomorrow, same time,